Basically, what we will cover here means like how what is cloud technologies and what is DevOps. In DevOps, what are the tools they have utilized and what we will cover here. Like 2 months of the course. Out of these 2 months, about what tools and technologies we will cover here. Those things we will discuss. Okay. So first thing, coming to cloud technologies. Any one of you know what is cloud technology? Simple meaning based on your understanding. Any one of you know this cloud technology? Nowadays, like you are hearing a lot cloud, right? So basically, cloud means so before cloud. We will not go to cloud now. We will see before cloud. Suppose some XYZ person has to start a company. There is no cloud technology as of now. Think about you have you need to start a company so that you need to have servers, right? Because if you want to deploy application, you definitely need a servers. Suppose you went to market and you bought two servers, right? Once you bought the servers, you need to set up somewhere, whether it in your home or in your office, whatever it may be. So you need to set up those servers. For that, you need power supply. If it is getting heating, like you need cooling system, and you need like networking as well. So all those aspects you need to take care here. Amount what you have spent to bought the servers, as well as you have to pay for cooling, you have to pay for power, you have to pay for networking, as well as you need one Linux engineer to maintain the servers. Suppose this is my laptop, right? So see here, I have updates here. These updates and all I need to do myself. So these activities and all you have to do on your own. But let me share my screen. Sorry. So if you see my screen, this is my laptop. These are the updates available for my system. So these updates and all I have to do. In a similar way, if you bought any physical servers, you have to do it on your own, right? Everything has to be done by your own, as well as money also. You have to invest more. Suppose your application got popular after 1 year. Those two servers are not sufficient, right, to handle the load. So you need to buy another 10 servers. Again, you have to spend money and you have to configure with your networking system. You have to maintain those servers as well. But after 2 years, your application not is not getting popular. Your load is getting decreased. Then what are the servers you have bought from the market? You can't able to delete. You have to maintain those servers. All those aspects you need to keep in mind when you are setting up a company. You need to spend a lot of money to maintain these servers as well as to buy these servers. So in this time, what these providers like cloud service providers, they thought they will set up this thing in somewhere. Suppose we are in India. In India, we have in Mumbai region. Suppose we have it in Mumbai. So they thought that they will set up this entire servers, networking, cooling system, power supply in Mumbai region. From that Mumbai region, they're providing services to other peoples through internet. Remember, they will set up physical data center. Physical data center, how it will look like in a sense. See, suppose consider AWS data center. So it will look like this one. So simple example. So somewhere in the world or somewhere in the region, suppose region means based on geographical area. That means India is like one region, right? So in that region, in particular to Mumbai, they have set up this data center, physical data center. But we can't able to go there. We can't able to see the physical servers on all. So what you need to do means Instead of going to market, buying servers, maintaining networking, maintaining cooling system, maintaining Linux engineers to do the updates, whatever the activities they want to perform, all those things you don't need to worry now. Just you need to access it from internet. So suppose if I want to access these servers from this Mumbai region, I can log into AWS account. So like this, okay. Let me show you. I'll tell you how to create as well. So just example. So here, if I want to launch an EC2 instance, like I want to launch one server in Mumbai region. So that means Mumbai I need to launch one server. So here we can able to choose based on your location as well. Suppose I want to launch in Mumbai. Here I can go here. I can launch one server within fraction of seconds. It will not take much time. But in real time, if you want to start, if you want to buy a server, it will take some time, right? You need to buy server and you have to set up, you have to do networking, cooling system, everything you have to do. That will take much time compared to this cloud technologies. Basically, what I mean to tell is, sorry, one second. So what is cloud computing means? Basically, see here, cloud computing is the delivery of different services through internet. Any service, not only servers, not only network, not only applications, not only database, any services which required to you based on the requirements, all the services you will get through internet only. You don't need to worry anything. You don't need to buy servers. Suppose you need one server today. You can launch within fraction of seconds. You don't need to do networking. You don't need to do cooling system. You don't need to worry about power supply. Nothing to worry. Suppose we need 100 server tomorrow. Within 5 seconds, within 5 minutes, you can able to launch 500 servers. And then next day, you don't want those 100 servers. You can able to delete as well. Nothing to worry. When you move to cloud technologies, or whichever the services you need, either it may be database, servers, application, storage, whatever it may be, you will get through internet. That is like cloud computing. In a simple terms, any services, if you are getting through internet, that we will call it as cloud computing. Simple. So different like different people, they will tell in a different meanings. Just understanding purpose, what is cloud computing means, any services including servers, applications, storage, networking, anything related to your IT infrastructure, you will get through internet. That we will call it as cloud computing. Anything. So now you are storing some files into Google Drive or somewhere you're storing it, right? Instead of storing it in your mobile and all, you will store it in somewhere. That is one type of cloud only. Google is providing you one service, right? So that is like one type of cloud technologies only. You're not worrying about space. Suppose you need 15 GB, by limit will be there. After that 15 GB, you need 100 GB means you can able to pay amount to the Google Drive. Then you can able to get it right per monthly basis. So any cloud computing technology, any services related to your IT infrastructure or anything related to services, you will get through internet. That we will call it as cloud computing. Anyone has anything here? Not able to catch or something? Just simple. What is cloud computing means? Any services related to your IT infrastructure, you will get through internet. That is like cloud computing. Either it may be storage or servers or database, networking, any software. Okay, that is like cloud computing. So cloud computing what type of method they will follow means, so I'm launching one server now. Okay, so on what basis we need to pay amount means pay as you go. Suppose here, let me type it here. Pay as you go or use. So these method they will use. Suppose I launched one server. I have utilized for 1 hour only. Okay, only for 1 hour I have utilized. Then for that 1 hour only I will pay the amount. I don't need to pay for entire day. Remember, in real time, without cloud computing, if you bought a server, you need to maintain every day. Okay, but when you move to cloud computing, how much time you have utilized any services, for that time only you have to pay to the cloud computing service providers. Just remember, that is the advantage of cloud computing. See, nowadays, so many companies are establishing within 3 months or 6 months, right? Within one day, also, they're starting a company. How means using this cloud computing only. They're not worrying about servers, networkings, database, storage, everything, anything. Just they go ahead and start a company. They will start developing the application. Immediately, they will deploy to the cloud computing technologies. So that is how they're starting a company. Nothing to worry now. Everything you will get from cloud computing. Okay, any services. If you're working for AI, like artificial intelligence, if you're working for ML, machine learning, if you're working for any database related things, or you're working for web-based applications, any applications, if you want to deploy into the servers, they're going to this cloud computing only. That much easy nowadays, no. But earlier days, it's not like that. If you want to start a company, it will take some time. They need to set up the entire data center. That means entire networking they need to set up before starting a company. Then they will start a company. Then they will develop the application. So that we will call it as on-premise. Remember, if you have your own data center, that means if you are not moving to cloud technologies, if you are using your own servers, own networking and all, that they will call it as on-premise. Just remember, this one is like on-premise setup. On-premise means by your own, you have to set up servers, you have to maintain networking, you have to maintain cooling, power supply, everything if you are maintaining by your own, by buying the servers and all, that setup we will call it as on-premise. This setup was done earlier before cloud computing technologies. Nowadays, no one is doing. No one is wasting that money also. So this when you move to on-premise, right? Everything you have to take care. Okay, on-premise. But when we move to cloud technologies, it's easy. Any services related to your IT infrastructure, you will get through internet. That is like cloud computing. Okay. So what type of services they will be providing means email services they will be providing. Any services related to like storage, backup, data retrieval. If you want to create testing apps, you can able to create. If you want to work with data, you can able to work. If you want to work with audio or video streaming, you can able to use the services. Anything related to software or anything related to data storage, backup, anything. Not only Java based applications, not only React JS applications, or not only for Python based applications. Any applications, if you want to deploy, if you want to maintain these applications, you can go for this cloud technologies. It will support everything. You don't need to worry. So suppose you have deployed your application into one server. So That server need this kind of updates. You don't need to worry. They will take care. Whoever the provider, suppose you have chosen provider as AWS. This AWS engineers will be there for that company. They will take care. You don't need to worry. Only you have to utilize the services through internet. How much time you have utilized, for that you have to pay amount. They will not ask you that you launched one server, you are deleting after 5 minutes only. They will not ask you. Only for that 5 minutes you have to pay amount. Just remember that much easy in cloud computing. You can launch n number of servers. There is no limit. You can launch. So these are the top 10 providers. Suppose cloud computing means, so instead of setting on-premise setup, these people they will set up around the world. All over the world, these providers they will set up these data centers. Remember, these on-premise data centers they will call data centers, on-premise data centers. These people they will set up. They will invest huge amount to set up data centers across the world. In suppose India, when we go for India, we have it in Mumbai, and then one more data center we have it in Delhi. One more data center is in Hyderabad. Hyderabad is not at live, but Hyderabad they are setting up. So three data centers are available for Amazon. Likewise, Azure as well. They have it in Chennai, Mumbai. One more they're setting up somewhere. I think Delhi or somewhere they have. So like this, these providers around the world they will set up physical data center like this. These physical data centers they will be setting up across the world. They will invest huge amount of money. They need power supply 24 by 7. They need cooling system. That means water they need. Everything they will take care, and then they will set up the data centers. Some engineers will be there for them to work related to this data center activities. You don't need to worry. You just need to access those services from internet to launch and servers, whatever it may be based on your applications. Okay, that is like cloud computing. Providers are available based on your requirement, based on your company. They will choose these providers. Okay, popular one, 60% of the cloud providers means 60% utilization means only AWS only. Remaining all these things little like it's not that much popular, but AWS is like popular. Okay, these are cloud providers. We have AWS, Azure from Microsoft, Google Cloud, Alibaba Cloud, Salesforce, Dell they have, IBM they have cloud, Digital Ocean one more cloud, and Dropbox. Like this, they have there are n number of providers. You can choose based on your company. They will choose. You need to utilize those cloud providers. Just remember what is cloud computing means. Any services related to IT infrastructure you will be getting through internet. Simple. That is like cloud computing. So now you went to cloud computing and you have seen the definition and all. So for everyone they will not provide one kind of technologies, right? Suppose I'm a like middle based company, mid level company. One more company is like high company is there. They can able to spend much more money compared to me, right? So they need different services. So likewise, in cloud computing as well, there are different types of clouds. Okay, types of cloud they have. Suppose I am a mid-level company. I don't want private connections. Private means they will give you access to entire data center. So this entire data center I need to get for myself only because I can't able to pay amount for this one. If you are able to pay that much amount for the AWS cloud, you can go for this private cloud. When you move to private cloud, right, you have to take care everything, like irrespective of power supply, cooling system. When you bought a data center for yourself, you have to maintain everything. If you are required assistant from AWS cloud, they will support you. So basically, private means it is dedicated to your company only. Other people's they can't able to launch a server in that particular data center. That we will call it as private cloud. They will call. And then public cloud we have. In this public cloud, anyone can launch a server. Suppose I am logged into this account, right? So in this same Mumbai region, you can also launch one more server. Different peoples around the world, they can able to launch a servers or services. So these many services they have. All those services they can able to utilize in this public cloud. Just remember, public cloud means anyone can access, anyone can launch a service. Okay, that is like public cloud. So what are the public cloud providers means? These are the public cloud providers because they are giving services to everyone. They are not giving services to a particular company. They are giving services to everyone around the world. So these are the public cloud providers around the world. Okay, public cloud means, just remember what is public cloud means. Anyone can access over internet. They can deploy the servers, database, networking, whatever they want. That is like public cloud. It is shareable. It is not that dedicated to you only. It is sharing capabilities it has in public cloud. Because suppose I'm launching one server, other person is one more server they're launching. It is sharing, right? It's not that dedicated to you only. In public cloud, everything will be sharing capabilities they will be having. Just remember, sharing capabilities they're having. In private cloud, it's not like that. It will be dedicated to you only. That is like private cloud. And then one more thing we have hybrid cloud. What is this hybrid cloud means? Suppose Accenture is there. Consider Accenture is the company. So that is a old company or TCS. Consider TCS that is a old company. So before cloud computing, they might be having data center, right? Separate data center. That means on-premise data center they're having, right? So they spent lot of money to set up this data center before cloud computing. Now cloud got popular. Everyone is using cloud technologies. So now they can't delete this data center because they spent lot of money, right? So what they will do means they will utilize this on-premise data center 50%. Suppose I have an application, Amazon application is there. So when you accessing Amazon application here, when I go Amazon.com, I'm entering. I have entered this one. So I can able to access this application like this. What they will do means this application related data, everything they will keep it in on-premise data setup. On-premise data center, they will keep everything related to code or application data, whatever it may be, they will keep it here. Only the front end, that means only the UI, they will deploy to cloud technologies. Why? Because they are not trusting these cloud technologies. They will keep a data and application code into their on-premise setup, and 50% of the application like front end, those things they will deploy into cloud technologies. That type of methodology if you are using for your application, we will call it as hybrid. Both public and private it will include in this hybrid. Public means public cloud provider. Anyone can access, anyone can deploy. Private means no one is able to deploy, but only the person dedicated to that data center he is able to deploy, right? That is like private. Both if we combine, hybrid cloud will call. It has both on-premise as well as public cloud. That is like hybrid cloud. These are the cloud computing types we have available in cloud computing. It's not only for AWS. These basics are same for any cloud provider, either it may be Google, Oracle, or Microsoft Azure, AWS, all cloud providers. These are the basics. If anyone is not able to understand, just ask me. Okay, these like cloud computing types. How many types we have means public cloud, private cloud, hybrid cloud. In that meaning, naming only you can able to understand. Public cloud. Anyone can access, anyone can deploy the servers. That is like public cloud. Private cloud means it is reserved to one particular company or one particular client. They need to take care of everything. Hybrid cloud means combination of both public and private cloud. Okay. So these are the three types of cloud computing we have available as of now. Okay, suppose now you have chosen public cloud, right? So anyone you can able to deploy servers into public cloud. In this public cloud as well, what type of service you need? Those delivery models are these three: infrastructure as a service, platform as a service, software as a service. Suppose consider I don't know coding, I don't want to deploy, I don't want to develop any application. I just need a service. Suppose Microsoft Outlook is there, okay, as well as um, Teams is there. Those applications we haven't deployed, we haven't developed, right? We are just using these applications. That kind of service I need, then I can go for this SaaS, software as a service. That means that cloud provider, they have developed their application, they are maintaining that application, they are maintaining servers, they are maintaining data, their application code, everything they are maintaining it. We are just utilizing that application. Then that kind of service will call software as a service in cloud computing. So in cloud computing as well, you have to choose what type of service you need. It's not that simple. Go ahead and launch a server. When you're launching server as well, you have to decide what kind of service you need to utilize from the cloud computing. Okay, just remember. So if you see here, infrastructure as service and platform as service and software as service. So these three types we have in service delivery models. Cloud computing types are public cloud, private cloud, and hybrid cloud. In cloud computing, what kind of service you need from the providers like AWS, Azure, GCP, all those things, these are the providers. From these providers, what kind of service you need, that you have to choose. Okay, these three services are available in cloud computing. Infrastructure as a service, platform as a service, software as a service. Okay, they will call as, PaaS, and SaaS. Simple meaning: infrastructure as a service, platform as a service, and software as a service. So consider infrastructure as a service. So when you need only till server, only need service from Amazon, consider Amazon is a one cloud provider. From Amazon, I need networking, storage, server, and virtualization. Only these options I need. I will install my own OS. I will maintain my middleware. I will maintain my runtime. I will maintain my data. I will maintain my application. So if you have capability of maintaining these things by your own, go for this infrastructure as a service. If you have a capability of maintaining these things, that means OS updates also you have to take care, and middleware you have to take care, runtime and data application, all those things you have to take care. Only Amazon they will support only till virtualization from networking. Only these four they will support. Remaining thing you have to maintain. These kind of service you need, then you can go for this infrastructure as a code, infrastructure as service, sorry. Infrastructure as a service. You can go for this one. Suppose I'm not a Linux engineer. I don't know how to install OS. I don't know how to maintain runtime. I don't know how to maintain middleware as well. Only I know my application and how to maintain my data. Only these two things only I know. Suppose consider you are a developer. You have developed entire code for your application. You just need to deploy that code into some servers. Only you have to deploy. Nothing to worry. Then you can go for this platform as a service. Till from networking to runtime, all those services are maintained by cloud provider. Only you have to maintain data and application. That type of service you need, you can go for this platform as a service. Okay. In this platform as service, everything they will maintain. Only application and data you have to maintain. Out of this one, if you don't want to maintain application and data as well, if you don't want, then you can go for this software as a service. Everything they will maintain. You don't need to worry anything. They will develop the application. They will maintain data. They will maintain OS. They will maintain servers. They will maintain storage. They will maintain networking. Everything they will maintain. You just need to access that application. Just use it. That kind of service they are providing means if you need from cloud provider, go for this software as a service. So these are the three types of services available in cloud computing. Okay, it's just not that they're not giving options to you. They're giving options. They're giving types of cloud. What type of cloud you need? What type of service you need from us? All those options they will give you. You have to choose based on your requirement. In companies as well, they will choose. It's not that by going to account and launching services. They will decide what kind of service they need for their application, for their organization. All those things they will take care. Okay. As I mentioned, one more you can be able to see right here on site is there. These like on premise. From networking to application, you have to maintain. You have to manage all those things in on premise. No one will support you. Everything has to be taken care by your company only. Okay, that is like on site or on premise they will call. Okay, now this on premise setup they are giving as a service from these providers. Okay, so from these providers you are getting services that will call it as cloud computing. Okay, so when you move on, like what are the advantages of the cloud means, like cost savings. See, instead of spending money on buying physical servers, maintaining networking, maintaining cooling system, you don't need to worry now, right? When you move to cloud computing, Everything is was saved. Only you have to pay how much we have utilized. It may be hour, it may be days, it may be months, or it may be one year or 3 years. When you move to cloud computing, cost for your spending to servers and maintain networking and all, it will be less. Okay, and then it will have more advantages latest for the latest application. Suppose you have developed one application somewhere in the like suppose if you are staying in US or somewhere, you need to send a money to your Indian account. It is happening within uh, like hours. It will take. It is happening, right? How it is happening is using this cloud technologies only. They have set up like that connections across the world. High speed. High speed means within fraction of seconds you can able to deploy servers, whatever it may be. Anything can be deployed within fraction of seconds in cloud computing and backup and restore data. In cloud technology, suppose you have deployed an application that has data. That data can be backed up. Suppose your application is running on Mumbai region. You thought that by next year some floods will come, the data center will get affected. Then you will lose your data, right? What you will do means you will take backup of your data. That same data will be deployed into Delhi region, Delhi data center. If something goes wrong with Mumbai, you will use that data to restore your applications and all. Those capabilities also available in this cloud computing. And then automatic software integration. That means these are this is the example. So these updates and all, you don't need to worry. Everything will be taken care automatically. Okay, like reliability means you don't need to worry about latest changes or updates available within the market. Everything will be taken care by cloud providers. Okay, just remember everything will be taken care. Unlimited storage. You can store petabytes of data as well. If we have not terabytes, petabytes is the more. If you have petabytes of data, if you want to store in cloud computing, that also it's available. It's not that only you can store 1 TB of data or 100 TB of data. It's not that. You can store petabytes of data in this cloud computing. Okay, that is these are the advantages when you move to cloud computing. And then for every application, if you know, right, for every application there will be some advantages as well as there will be some disadvantages as well. For this cloud computing as well, there are some disadvantages. Performance can vary. Means suppose your application was deployed into Amazon cloud. Some hackers are trying to access our application. That time your application performance can vary. Maybe it will be slow or someone will be hack your application. But they will not give you 100% security. Remember, anytime if you are moving to cloud technologies, they will not give you 100% security. Only 99.9% they will tell you. 0.1 percentage they will not give you, because there might be some actions will be happen. They cannot show that it's like 100% security. Okay, everything like downtime as well. Suppose some floods came in that Mumbai region, that data center is gone now. That is like downtime for your applications, right? You can't able to do anything. Suppose nearer to the data center, the transformer got blown. Now power supply is stopped for the data center. That effect it will come to your applications, right? So these things and all, they will not give you 100%. Okay, these are the advantages. And then without internet, you can't able to access your servers which are deployed into these cloud providers. Internet, good internet connectivity is must to access cloud computing. Without internet, it's not possible to you to access the servers which are deployed into this cloud computing. Okay, as well as support. So when you call Amazon, right, some Amazon support engineer, they will pick the call, but they will try to help you on the call only. If you are a non-technical person, you can't able to understand, right? So that lack of support also is there from these providers. So these are the disadvantages of cloud computing. So that is the reason if you go to any banking system, SBI is there. They haven't moved their applications to cloud computing. No. Still they are maintaining their servers in on they are maintaining their applications in on-premise setup only. Why? Because they are not trusting these cloud providers. Why? Because security. Main purpose security. If they host their application into cloud computing, if something attack was happen on that application, they can able to see everyone's credit card information, bank account, balance, every transaction details they can hack, right? So for that reason, nowadays as well, some banking systems they haven't moved their applications from on-premise to cloud computing. Advantages are there, disadvantages is there. So based on that, you have to choose. Till now, it's not 100% everyone has to move to cloud computing. It's not. No, there are some people they haven't moved their applications. Okay, these are about cloud computing. So coming to what we're going to cover in this course, in the sense we will cover this AWS. Okay, we will see different services here. So if I go to here, these many services we have. Okay, so we are not teaching analytics. Suppose we are not working for analytics, we are not working for blockchain, we are not working for database, we are not working for front end applications and all. So as a DevOps engineer, what are the services you need? Those services we're gonna teach you in this Amazon cloud. Okay, when it comes to cloud computing technology, we will cover this AWS cloud computing technologies for 1 month, like 20 to 25 classes will be there. In that 20 to 25 class with practicals, we're gonna teach about this AWS cloud. Okay, these are about cloud computing. Okay, if you go anywhere, these are the basics of cloud computing. What is cloud computing, types of clouds, and what type of services they're providing. These things you have to remember. Okay, if you have anything you can ask me, otherwise I'll move to DevOps. Okay, so now coming to DevOps. So what is this DevOps? Nowadays if you go out, you can see a lot of openings: DevOps engineer, DevOps engineer, DevOps engineer. So why cloud? Cloud and DevOps engineer, they're calling it nowadays, right? Why? Because these cloud computing technologies can be taken care by DevOps as well. This DevOps engineer can take care about cloud as well as DevOps. Okay. So now we have seen cloud. What is cloud? What are the type of clouds we have? What type of services we can get from cloud computing and all we have seen. Now DevOps. What is this DevOps? So basically, before DevOps, right? This like 10 to 15 years you were hearing a DevOps. Before DevOps, how it will look like in the sense. Suppose I am a developer. Okay, I'm a development team. I have developed some code for that application. It is running my laptop. That is fine. So now that same code has to be deployed into servers. Consider in cloud computing, I have launched one server. In that code, in that server, I need to deploy my code. I have given to operations team. That means in your IT team will be there in your company. I have given that same code to IT team. Now that same code is not able to run in that server. So now IT team, what they have to do, they have to come back again to development team. They need to look for the developer. They need to ask him why it is not working in our system, why it is working on the system. Please do modifications. This process is hectic. Hectic means it is very difficult to IT team to reach out to developers, trying to ask to resolve the issues as soon as possible, then again take the code, run the simulations, then deploy it. This communication between developer and IT operations team is difficult before DevOps. So, to fulfill that communication gap between developer and IT support team, DevOps came. Just remember what is DevOps means. It's not an application, it's not a software, it's just a methodology. So, what it will do means it will establish strong communication between software development team and IT operations team so that application delivery it will go smooth. Okay, just remember, just DevOps means it's just a methodology in software development. Okay, it will improve the communication between developer team and IT operations team so that application delivery it will go smooth. So that is DevOps. So in this DevOps there are lot many tools that we will see later. So just remember DevOps means is just a methodology between developer team and IT operations team. So now this DevOps engineer what he will do means he will take the responsibility. Suppose IT team is facing some issues. That that issues it will come to DevOps engineer. Then he will look into that issues. Then he will reach out to developer team as soon as possible. It will resolve that. Then take the code again. It will give to IT operations team so that they can delivery. They can deploy. So this communication between DevOps, like developer team and operations team, DevOps engineer will take care. Just remember, DevOps engineer the roles are like to establish the communication between developer and operations team. Dev plus ops, that is like DevOps. Okay, communication between developer and operations team, that is like DevOps. So in this DevOps, we have life cycle. So in this life cycle, what it will include means first thing we'll be having plan. Planning means you have to do some planning, right? Suppose you are starting a project, you have to do some planning. Your project manager he will plan how many engineers we need, like how many days we need for this project, like who will work for testing team, who will work for a developer, who will work for deployment, what kind of tool you need for the monitoring. All those things you need to take care about your applications, right? It's just not that you'll go ahead and write the code and test it and deploy it. It's not that. There will be some strategy will be there. For every company, for any application, if you're starting from scratch, these steps will be included. First thing, plan will be there. Once planning is done, they will start development. Once development is done, they will build the code. Once build is done, they'll go for testing. Once testing is done, they will release the project. They will release the application. They will deploy into servers. Once deployment is done, they will operate that application. It's not that once you deploy that application into servers, it's not that your job is done. You have to maintain, right? If something goes wrong with that server, you have to take care. As well as we have to monitor that application, right? So this cycle it will continue. And this is the DevOps life cycle. Plan, code, build, and test. These it will come under dev. Once development is done, we will do release, deploy, operate, and monitor. This will come under ops team, operations team. So entire dev plus ops will call DevOps. Middle DevOps engineer will be there. So this DevOps engineer, he will make sure this process will to go as smooth as possible. Okay, he'll make sure. As a DevOps engineer, you have to make sure this process has to go very smooth without any difficulties. So this is the DevOps life cycle. So when you see one by one, right, what is plan? As I mentioned, as a product manager or project manager or PM or manager, assistant manager, or whoever it may be, they will plan for your application. What are the requirements we got from the client? Suppose I'm a like one client for your company. I came to you. I told you these are the requirements. I need application like this. So then your project manager or someone, they will analyze the requirements. They will start noting the points. They will think how many days it is required, how many developers we need, how much time it will take, and then how many test engineers we need, how many DevOps engineers we need to take care all this process. All these requirements step by step they will note it down. Once that requirement step is done, they'll go for coding. Then your coding team, either it may be Java based or Python based or Node.js, whatever the language they will use to develop that application. Once coding is done, they will do like a build phase. Build means once we have written code, that same code it will not work like that. You have to convert into some packages. That package will be done here. This build. From here, DevOps engineer he will start the job. Building. Once code is available, he will start build. Once building is done, that same packages it will be delivered to test engineers. These test engineers they will do unit test casing, like user acceptance test, and then different testings they will do. That would be like if you're a test engineer, they will do all kind of testings related to your code. Once testing is done, they did some testing. They told that your application code is good. You can able to deploy that application code into some servers. Then we go ahead and release the code. Finally, we will release into production. That means live. Once it is deployed, we have to maintain that application up and running without any issues. Like that, we will operate and we will monitor as well. This cycle it will keep on rotating. So consider you have an application, right? That application, see, now I went to one company, I told some requirements. They have developed my application within 3 months. They have released the application. Now my application is running on 1.0 version. Consider in our mobiles, right? On every Friday or 2 weeks once, application will get updated automatically, right? So they will be doing some development in background. They will be releasing it as well. So that life cycle it will keep on rotating. So for that 1.0 of my application, which is running on the production, that means anyone can access my application. So now again I went to my company. I told that I need these changes. Again, what they will do, they will plan, they will code, they will build, they will test it, they will release and deploy, operate and monitor. This cycle, it will keep on rotating. It's not that one-time job. Okay, just remember in DevOps, this life cycle, it will keep on rotating. Plan, code, build, test. After 6 months, again I came, I have given some requirements so that they will change. Again, they will plan, they will code, build, test. Everything will be taken care. As a DevOps engineer, you have to make sure this process has to go smooth. So in this life cycle, plan, code, build, test, release, deploy, operate, monitor. So these things you have to take care as a DevOps engineer. Just remember, for any application. Nowadays, one application they are giving as a live means, suppose you consider Amazon application is there. They will release that application within 3 months. How it is possible means they will develop the application with minimum requirements. Inside features, let it be. See, inside features can be added once the application is released as well. Okay, suppose consider WhatsApp is there. Like 2 months once or 1 month once it is getting updated, right? With some new features. How they will do means this life cycle only. They will plan and they will code the deployment, they will build, they will test it and release into the production. So this life cycle it will continue for all the applications. Nowadays we are using it. Any application, all applications in your mobile getting updated to new versions, right? So that process it is happening via this DevOps life cycle. Okay, any application. Okay, so now these are all about DevOps. DevOps means to establish communication between development team and operations team. This DevOps engineer he will take care this responsibility to make application releases as smooth as possible. Okay, just remember DevOps, Dev plus Ops, development plus operations team. As a DevOps engineer, you have to make communication, strong communication between them to maintain smooth relationship between these two peoples as a DevOps engineer. Okay, that is like DevOps and DevOps lifecycle. It will have these many phases for all the applications at present we are using in our mobiles. They will be following this DevOps lifecycle only. It's not that one-time activity. You have developed an application, you deployed, and everyone is accessing your application. It's not that single job. They will be adding more features to your applications that they will take care like this: plan, code, build, test, release, and deploy, and operate and monitor. These steps will be continued for your applications. Okay, so these like DevOps basic meaning. It's not that depth, just basic meaning how it work. So moving forward, so when you like if you're working for a company or if you join to the company, they will tell you we will do continuous everything we will do. They will tell you. So the process which we have followed in DevOps, they need to continue everything. Suppose you deployed on a same application 1.0. Again, they will update that application with 1.1. After 2 months, 1.2, 1.3. Like that, they will keep on updating this application. They will do everything as a DevOps lifecycle. In this DevOps lifecycle, they will keep on updating your application with this DevOps lifecycle. That means they will continue that process. It's not that they will stop that application. They will keep on updating. That is like continue everything. You have to continue development. You have to do monitoring. You have to do feedback. You have to get integration, delivery, operations, testing. Everything you have to continue. There is no ending for that application. So they will nowadays when you enter the company, if someone says continuous everything means they will keep on rotating this cycle for the same application. Okay, that is like continuous everything. So in this process in DevOps, we have CI and CD, continuous integration and continuous delivery. So continuous integration means for this, suppose you're working for a Amazon project. Okay, suppose consider you're working for a project. So there will be some developers will be there, right? So those developers, it's not that single developer he will develop the code for the entire application. There will be hundreds of developers will be there for the same project. They will be developing the applications, developing the code. Sorry, they will be developing the code. So if you integrate all people codes, you will come on applications, right? It's not that one person code will be one application, one more person code it will be one more application. You have to combine all people's code, all developers code, then only you will get actual applications, right? So that we will sync in one folder. Consider in one folder, we will take all developers code and then we will combine that code as a package. Then only our application will come. So this process on every day, developers will write the code. This process will be same. Every day they will write the code. They will deploy into one folder. Like I am telling now as a folder. There will be other terminologies I will tell you later. But consider you have 5 developers. They are writing the code on daily basis. End of the day, they have to push their code into one folder. Okay, this process has to be continued. They have to push their code on daily basis. Just remember, on daily basis they have to push that code into one folder. That process we'll call continuous integration. Continuous integration means for one project multiple developers will be working on. So on daily basis they have to push their code into one repository, suppose one folder. That code they will do compile testing, whatever maybe they will do. So this process it will continue on daily basis, it will continue. This process we will call continuous integration. Just remember, continuous integration means on daily basis developers will be developing the code. That code has to be pushed into some repositories. This process we will call continuous integration. Okay, it's not that single developer will be working on one application. There will be multiple developers. You have to take all their code and you have to merge it into single folder. This process will continue on daily basis. This process you can't do manually. So on daily basis you can't go into each developer asking them to push the code. They have to do it on their own. It has to be automated. That process we'll call continuous integration. Okay, so once development is done, they develop, they have written the code. Now code is ready. So out of that code, you will get the package, right? Suppose you have got one package file. Suppose your application bundle, your application entire code, if you combine, one bundle it came. That bundle you have to deliver to servers. Now, once application code, suppose I have written some code here. This code it will not run the application, right? So it has to convert into one package. This package I need to deploy into one physical server. Either it may be cloud or it may be on premise, right? That deployment will call continuous delivery. Each and every day they're writing the code, it is getting converted into build, they will do automated testing, all those things it will cover. Finally that application bundle has to be deployed into one server. That if you want to automate that one, you can go for this continuous delivery. Okay, continuous delivery means on daily basis, which are the code the developers are developing, that each and every change you will get one build. That means one package. That same package, if you want to test it and if you want to deploy it, you can go for this continuous delivery. And one more thing we have continuous deployment. In CI/CD, just remember in CI/CD, so CI/CD they will call. Okay, continuous integration, continuous deployment. Inside this one, we have CI, CD and CD. Okay. CI/CD means continuous integration and continuous deployment. Basically the meaning. But inside we will be having continuous delivery as well. Continuous delivery and deployment. Same thing. Once code is ready, that code you will deploy into any servers. What is delivery means? Suppose consider if you want to do in a manual. See here, once code is there, you test it and you have integrated and then one more testing they did. So now if you want to deploy to the production by manual, suppose you need to log into that server, you have to click to deploy that code. That process will call continuous delivery. Suppose if you don't want to do it as a manual, it has to be automated. Suppose once code is ready, it has to do testing, it has to integrate, and it has to do acceptance test. Then it has to finally deploy to the production. This process has to be automated means we'll call continuous deployment. This is the difference between continuous delivery and deployment. If you want to automate everything from code to deployment, go for continuous deployment. If you don't want to automate entire process, you have to interrupt that deployment means go for this continuous delivery. So this you will come to know like once courses has been started. Just remember what is continuous delivery and continuous deployment means. Once code is ready, test engineers they will test it, we will integrate it, and then we will deploy to the production. Okay, production means live. Live means you are accessing the application from the browser. That is live. So okay, so that process if you want to automate, you can go for continuous deployment. If you don't want to automate everything from code to deployment, go for continuous delivery. So these are all about continuous integration and deployment. CI/CD in DevOps main part, continuous integration and continuous deployment. Okay, CI/CD. So as I told you, like every time what are the code we have deployed to the production, you have to get the feedback every time. If something is going like monitoring will be doing, right? So based on that monitoring, suppose something was happen, you will come to know, right? Then you have to do improvements. So every time in DevOps, feedback is important. Based on the feedback only, you will try to improve your application like security or development or testing or deployment. Everything has to be improved. It's not that DevOps engineer part is like once code is ready, deployment is done. Continuous feedback is very important in DevOps. Continuous development will be very important in DevOps. Okay, DevOps engineer, he has to take care this entire CI/CD part. Just remember, entire this CI/CD part has to be taken care by DevOps engineer only. In this DevOps life cycle, so this continuous integration will come into dev, continuous delivery it will come into operations part. In this DevOps life cycle only, CI/CD it will come. Okay. Remember, if you see is here green continuous integration from code to build continuous integration. Continuous deployment from blue to see here. Still deployed is a continuous deployment. So you have to integrate your DevOps lifecycle into CI/CD. CI/CD it's not a separate. In DevOps lifecycle only, those two it will come. Continuous integration and continuous deployment. CI/CD. Okay. So these are about DevOps. So in this DevOps, these many tools are there. Okay. Just remember these many tools are available in the industry. Based on your company, what kind of tools they want to utilize, up to them. It's not that uh, it's not standard format. Someone is telling you how to utilize this tool. No, it's not. They will be using different tools for the same job. Suppose build. these many tools they have. It's up to them what kind of tools they want to utilize. For each and every step in DevOps, different tools, but functionality is same. Just remember, don't get confused if someone asks you, you learned some one tool. Consider you have learned Jenkins. Okay. Suppose here for integration you have Jenkins is there. Jenkins, if you have utilized for this, suppose you have learned Jenkins for now. If someone asks you what is the CI/CD tool you have utilized, you tell Jenkins, but he will tell you like we are not using Jenkins, we are using some other tool. But functionality is same. Just remember, functionality is same across all the tools, but naming convention, pricing, that UI of that application, it will change. But functionality, it will be same across all the tools. Whatever we're gonna teach you in this course, that is like basic for all the tools. Okay, just remember these many tools we have in the market. Okay, what we gonna select out of this DevOps life cycle, I will show you next slide. Okay, so these all about DevOps tools. Just remember DevOps life cycle is main. Dev part it will call it as continuous integration. Operations part we will call it as continuous delivery deployment. Okay, everything has to be automated here. It's not that manual. Once code is ready, you have to build it in an automated way. Then you have to test it. You have to deploy to the environment. Everything will be automated in DevOps. It's not that going and clicking manually. It will be automated everything. Once developer completes the code, as a DevOps engineer, your job will start from this build. Once plan and code is done as part of this DevOps life cycle, planning is done by project manager, coding will be done by developers. Once coding is done, from this build, our job it will start as a DevOps engineer. Okay, all those things it will start from here. Build from middle test engineers they will come. Build, test, release, and deploy, operate, and monitor. All those steps will be taken care by DevOps engineer only. Continuous integration and continuous deployment. Okay, in this example only, continuous integration means once code is ready, you will need to build it in an automated way. Once build is done, you have to deploy to servers. These are like CI/CD. Okay, these are about DevOps. Any doubts here, DevOps? So these are all about DevOps and cloud technology. So these like basic. We haven't been in depth into DevOps and cloud. We're just covering for the demo purpose only. Okay, and then when you enter into the projects, right? Suppose you're working for a project, you're working for a company. Okay, they need to start some development of the application. They will follow some methodologies. It's not that simple, you'll go ahead and start application coding. They have some planning. So that planning in software, they will call software development lifecycle, they will call SDLC, they will call. So in this SDLC, what are the phases they will have? Planning will be there. Suppose I'm a client, I went to Accenture. I have told that these are my requirements. I need one application. Okay, that is like planning. Once you have given the requirements, they will analyze the requirements. Okay, based on their company capabilities, whether they can able to do it or not. How many developers we need, how many test engineers, all those planning they will do. Once analysis is done, they will go for design. That means coding they will go. Once coding is done, they will deploy that application into production. Then they will maintain that application. So these process will be there in any software application. Any software application, if you go into any software company, these process will be there in any application. That methodology they will call software development lifecycle. In this software development lifecycle also, there are types of software development cycles. What kind of development strategy you have to utilize? So popular ones, one is like waterfall and agile methodology. These two things I will cover and I'll close it. So what is this waterfall methodology means? So maybe if you have any relatives who has more experience, 20 plus or someone, they might have seen this waterfall methodology. What is this waterfall methodology means? Suppose if you're working for a project, it's not possible to you deliver the project within 6 months or 3 months. Nowadays you are seeing it. One application they can able to deliver within 3 months or 6 months. But in olden days it's not possible. Because in software development lifecycle, they are following this waterfall methodology. In this waterfall methodology, you have to go by step by step. There, see, it will take 1 year or 2 years or 3 years for the single application. So, what they will do is they will start project planning. Then they will gather requirements. They will analyze these requirements. Then they will start designing. That means once designing is done, they will go for coding. Once coding is done, then only they can able to go for testing. Once testing is done, they will deploy the application. It will be live. So here, if coding is not completed, testing people they can't able to do this testing. That is the reason when I go for test engineer's job, their job will be very easy in olden days. Nowadays also it's like little bit easy, but nowadays test engineers are utilizing on monthly basis. In olden days, test engineers in entire year they will work only 1 or 2 months or 3 months only they will work. Remaining days their job will be very like light. They don't have much work. They will enjoy their jobs as a test engineers. So because they will wait for development has to be completed. In this waterfall methodology, one stage it will be depends on other stage. It's not that from requirements you can't able to do coding. Once coding is done, you can't able to deploy directly. You have to do testing. Till testing completes, you have to wait for this stage to complete. Then only you can go for this second step. That means this process sequential order, right? This is like sequential order. One stage is depends on another stage. If that stage is not completed, you can't go to next stage. In this waterfall methodology, this is the process. Step by step you have to go. You can't skip any step here. Okay, so that any project in a software company, it will take 1 year or 2 years or 3 years to complete that application. But nowadays, you are seeing it, application will be released within 3 months or 1 month also. How that is happening means latest trend is like agile methodology. In this agile methodology, they will include everyone within a month. It's not that suppose you went to one company, you told that you need one application within 2 months. They will not deliver entire application within 2 months. They will give you one part of application to you within 2 months. Suppose 1.0. Client will be happy. He got delivered application with some features. They have included developers, they have included test engineers, they have included Devops engineers, they have included everyone in the process. Requirements, all this process has been included in this within 1 month. They will deliver the application with minimal features. Okay, and after that, once that release is done, They will deploy other features again. Again, they will deliver one more version of that application. In this agile methodology, this process it will work as like this DevOps engineer life cycle. This process it will continue in this agile methodology. That is the reason agile methodology is like DevOps life cycle. They will include everyone. Okay, test engineers they will include in each and every step to test each and every build nowadays. Agile methodology they are following it. Just remember when you go for waterfall methodology, it will go for sequential cycle. It has to be depends on one like step. To complete that step, then only you can go for next step. These like waterfall methodology. But in agile methodology, it's not that. Some part of the code you can take. See here, this meaning. Agile methodology is a project management approach that involves breaking the project into phases. As I told you, as an application, they will break into 1.0, 1.1, 1.2, 1.3. They will start delivering the application of 1.0 first. Then they will go for 1.1. They will go for 1.2. Like that, they will process the application development, they will process the testing, everything they will include. So, continuous collaboration and improvements. Teams following a cycle of planning, executing, and evaluating. All this process will be included. See, developers, clients, users, everyone will be included in this one type of one phase. Everyone will be included. It's not that only developers has to write the code. They will include test engineers as well. Suppose today developer have written some code. Today, tomorrow only it will be tested. They will not wait for long in agile methodology. So that is the advantage of this agile methodology. Nowadays, all projects in all software companies they are using this agile methodology only. That is the reason you are seeing it. Applications will be releasing frequent releases 1.0, next week 1.1, next week 1.2. Like that, how they are releasing means for their development, software development life cycle, they are using this agile methodology. Olden days, they are using waterfall. This it will taking much more time to complete application development as well. But in agile methodology, frequent phases they will be releasing it. Okay. In this software development life cycle, they are using this agile methodology nowadays for any application. Just remember, for any application development, they will be using agile methodology only. Okay. So these are all about basics about cloud, DevOps, and for any application, what kind of software development lifecycle they are using it. If you have anything, you can ask me. And then what we're gonna cover in this course means we will cover these things. AWS is the cloud, and we will teach Linux. When you want to work with the servers, you need little bit of Linux, and then Git for storing the developers code and all. Git they will utilize, and Maven for build, and SonarQube for static code analysis. That means once developer has written the code, that code has to be scanned. That means scanning means whether they have followed some certain rules or not. That can be done by SonarQube. And Jenkins is the CI/CD tool. In DevOps lifecycle, Jenkins is the CI/CD tool. And Apache Tomcat is the like package. Like once your code is ready, using Jenkins, we will take the code from GitHub repository, we will build it. From the build, we'll convert into package by using this Tomcat. Okay. Once package is ready, we can deploy to EC2 instances, which is in the AWS cloud. And Ansible is like configuration management tool. We will cover. What this Ansible it will do means, suppose you have a server, you have one application. It is running on the server. You want to update or if you want to install something on that server without logging, then you can able to do using this Ansible. Okay, and then Docker. It's like when you want to containerize your application, you can go for Docker. And then when you want to do container management, then you can go for this Kubernetes. So this entire process in DevOps or AWS services, when you can log into AWS account, and then you can launch a servers and all by manual you're doing. If you want to do entire cloud and DevOps in automated way, we can go for this Terraform. So this Terraform two classes we will gonna reach. So these are the cloud and DevOps tools we're gonna cover in this course. So these many hours, maybe it will vary. It's not that only 1 hour or 3 hours or 4 hours. It will gonna vary. It will gonna to go for more only. Suppose I mentioned 20 to 25. It will gonna go 30 hours, maybe 2 to 4, 3 to 5. Like that, it will gonna vary. Okay. So these are the services and these are the tools we're gonna teach you if you join this course. Okay. Like it's not that single person is teaching. Whoever has expertise in these tools, we're gonna teach. We will be teaching two peoples. One person he will be teaching Linux till Ansible. Okay, one person, and I'm gonna teach you AWS and Docker and Kubernetes and Terraform. Okay, two peoples we will teach you people. Like it's not that single person. Single person able to cover, but expertise is main. So that is the reason one person has expertise in these tools, one person has expertise in these tools. Okay, just remember, when you join a company, you don't get work on all those tools and technologies. Maybe you'll get only on AWS. One project will be there only on AWS. One more project will be there only on Kubernetes. One more project will be there only on Terraform. One more project will be there only on Jenkins. It's not that all tools you will get in a single project. It's not that. Just change your mind. Project to project, it will be varying. Sometimes you will be working on only on Kubernetes. Sometimes you will be working on only on Jenkins. So like this, it will vary. But we will cover all those things. Yeah, that is all about today's demo. And please do reach out to Venu if you are interested to join this course. Thank you all. If you have anything, you can ask me, otherwise, you can drop off.